Hi there. In this section, um, we're not really doing anything new. Um, we're just going to solve equations by factoring. We've already done that to some extent, and then we're going to do some more word problems. And I know that the word problems are the tricky thing, but they're good for you, and they help you really understand the mathematics. And the more you do them, the better you get at it. So if you're frustrated, just keep working at it and ask me for help. Now, I just want to revisit this important topic, the zero product property. The reason that we've been spending all this time on learning how to factor, and in particular factor trinomials, is because to solve equations with that are greater than degree 1, we have to use this zero product property, which tells us if you have, this could be some expression and this is some expression, if they're multiplied together and equal 0, then either this first set of parentheses is 0 or the second set. And this can be extended to more than, you can have A, B, C, and so on. Now you have 3 factors, and you'd set all 3 factors equal to 0. So if we want to solve a polynomial equation where the degree is bigger than 1, we want to put that equation in what we call standard form. You have the expression, which for us right now is a polynomial, on one side and 0 on the other. Once you've done that, then your goal is to factor that expression. If you can't factor it, we learned some other techniques in chapter 6, but for now, we will hope that we can factor it when we're asked to solve. And the reason we factor is because it lets us use the zero product property. For example, if you look at example 1, if you were asked to solve something like this, it might be really tempting to divide both sides by x plus 3. Like, can we just get rid of that? And then you would end up with something like 5 equals 5x, which is now a linear equation. So you could have 5 minus 5x equals 0. And you might think that that's legal, but it is not. We cannot divide both sides by x plus 3. Why not? Why is that such a big deal? Well, remember, you cannot divide by 0. And you say, well, I'm not dividing by 0, I'm dividing by x plus 3. Well, included in there is when x equals negative 3, then x plus 3 does equal 0. And it turns out that that's very important because that's one of the solutions, negative 3. So resist the temptation. Do not divide both sides by an expression or by any variable. What do? We get the polynomial on one side and 0 on the other, and factor. I can't emphasize this enough. I see students try to do this in upper level courses. So how would we solve this? Well, let's use our technique. It said we have to get the polynomial on one side. Well, how do we do that? Well, we want this to be 0 over here. So subtract. We can subtract 0 from both sides. That's not a problem. We're not breaking any rules when we subtract this from both sides. And then we can write this. 5 times x plus 3 minus 5x times x plus 3 equals 0. And then we recognize that this has a common binomial factor that we can pull out. This is a common factor. So what's left when we factor out x plus 3? Over here, we have a 5. And over here, we have a minus 5x. And we might as well completely factor this because you see there's a common factor here, right? So let's factor out the 5. We put that at the front. If you divide 5 by 5, you get 1. If you divide this by 5, you would have x equals 0. So now my solutions come from setting each factor equal to 0 and solving for x. Now, this is a factor, but this can never equal 0, so you don't have to worry about that one. So you put x plus 3 equals 0, or 1 minus x equals 0. Now, these are degree 1, so we know how to solve that. For the first one, this is x equals negative 3. Subtract 3 from both sides. This one depends on what you want to do. Suppose you subtracted 1 from both sides. Okay, then you have negative x equals negative 1. That's not what you want, so you have to multiply both sides by negative 1 or divide by negative 1 to realize, and obviously this is what x has to be, 1 minus what equals 0. I mean, you don't really have to do the algebra to see that that's true. And there are the solutions to that equation. Okay, now here's an example for us to work. First step, we want to get everything in standard form. Polynomial on one side, 0 on the other. So I hope you can see how to do that. You just subtract 12 from both sides. And then we're going to factor. Okay, so I know that this is going to be x and x, and then I have to figure out what goes here and here. I'm going to need a positive and a negative, but that will all work out when we figure out what a and b are, and maybe you can already see it. So in this case, little a, remember this is what we're looking at. Little a equals 1, little b is negative 11, and little c is negative 12. We need two numbers that multiply together and give us negative 12, and that add together to give us negative 11. And sometimes we get nice ones like this. Don't forget, this is a fact, this is a possibility. Negative 12 times 1. So, doesn't matter where you put what. One of these is negative 12. One of these is positive 1 equals 0. Before you solve, I think you should check. Make sure that this works. That's x squared. The outer gives me x. The inner gives me negative 12x. That works to give me negative 11. And last is negative 12. So good. So now we can solve. So either x minus 12 equals 0 or x plus 1 equals 0. So x equals 12 or x equals negative 1. All right. And there's another way to check your answers if you didn't check your factoring. This is a little more difficult. You can plug in values x equal 12, x equal negative 1 into your original equation and make sure it's true. Don't forget you have that also. All right, here's a word problem that I haven't even read yet. So, a cryptographer. What is a cryptographer? Somebody who studies cryptography, which is related to coding, codes, and such, but we don't really have to know that word. This person needs to arrange 60 numbers in a rectangular array. Okay, so we have an array. What is that? That means like this. I'm going to make a rectangular array. This would be a 3 by 4 array of dots. For this particular array, though, we need the number of columns is two more than twice the number of rows. So find the number of rows and columns. Okay, so what do we know? We know there's 60 numbers. So I'm just trying to get us started. There's 60 numbers. Let's let R be the number of rows. We have to choose a variable. It doesn't have to be R. Okay. And then C can be the number of columns. What do we know about columns? C is 2 more than twice the number of rows. Okay, so I have R for the number of rows and 2 plus 2R for the number of columns. Now, in my little example, we had a 4 by 3 array. How many numbers are in here? Well, this is 4 columns, 3 rows, and that is 4 times 3, 12 dots, right? So that's how 60 fits in there. We know the number of rows times the number of columns equals 60. So let's get a little more room and keep going. Let's see what we can do. We know there's 60 numbers, there are rows and C columns, but we use the information given to write the number of columns as 2 plus 2R. So really it's R times the number of columns, which is 2 plus 2R equals 60. And that's the hard part. Once we've got an equation, then we know what to do. Let's multiply this out. This would be 2R plus 2R squared equals 60. And that's the equation we need to solve. 2R plus 2r squared equals 60. Okay, back to just solving an equation. We're going to get it in standard form, so subtract 60. And we will rearrange this. 2r squared plus 2r minus 60 equals 0. Now we need to factor. What do we always do first, though? Look for a greatest common factor. Maybe they all have something in common, like the number 2. So factor that out to make life easier. Oh, this is going to factor nicely. Okay, so we have A equals 1, B equals 1, C equals negative 30. We know this is going to look like R and R, and we just have to fill in this blank. One will be positive, one will be negative. So we need A times B to equal negative 30. A plus B equals 1. So I already know what we're going to do. Negative 30, that can be written as 5 times 6. So let the 6 be negative. So we have R minus 6, R plus 5, right? Let's double check that works. We get R squared, we get minus 6R and plus 5R. That will give me, I got the signs wrong. Which, see, why it's a good idea that we double checked, right? We want this to be positive, don't we? And this to be negative. Now let's check. Outer gives me negative 5, inner gives me positive 6. Okay, so R plus 6 equals 0, or R minus 5 equals 0. So R equals negative 6, or R equals 5. Now, what the heck were we doing? You have to think back. What was R? R is the number of rows. So do we have negative 6 rows or do we have 5 rows? We can't have negative 6 rows. We have 5 rows. So we have 5 rows. And how many columns? Well, C equals 2 plus 2 times the number of rows, which is 5. So C is 2 plus 10. That's 12 columns. 5 rows and 12 columns. And that would give me 60 if I multiplied them together. Okay, so this is the book's version of solving it in case you want to go through that instead of listening to this lecture. This is in here because it's not going to come up right away, but it's bound to come up sometime during the course. And so somehow they just stuck it in this chapter. Everybody should know the Pythagorean theorem. You should never forget it. If you have a right triangle, that means this is 90 degrees. The length of this long side, which is called the hypotenuse, is related to the length of the two legs. We call the other sides legs. And how are they related? By this formula. The sum of the square of the two legs equals the square of the hypotenuse. A squared plus B squared equals C squared. All right, so this was a short lecture. There's nothing really new in it. Now, in the part 2, we will do these homework problems.